Hi, this is Russ Andersson. In this section of the tutorial, we're going to look at using the perspective view with 360 VR shots. And we're going to be setting up an object that later we'll be rendering. So in this section, we're starting from the results of section number 4, where we produced a world-stabilized camera, and we have the matching image set at bottom that is very stable. So that's our starting point. Now let's take a look at the perspective view. I'm just going to access that through the geometric hierarchy tracking room. And I can look around, with any kind of perspective view and all sorts of different applications. You can see what's in the 3D environment. Now, the idea is always to be able to see what's in that particular direction. And it is a perspective camera because it's the perspective view. But the images of the shot that we have, extend all the way around the entire environment, not just this one particular direction. So we need to account for that in order to be able to see the right thing in the perspective view. If I just use the images as they are, I'm seeing the entire image when really I should just be seeing a portion of it. So to set that up, we're going to go and first let's go to the solver room, and we're going to increase the world size value just to reflect really what the actual case is. And the world size number is basically an under the dome sort of number. Everything lives within that size of a dome. And it's used to scale a bunch of different things. And in this particular case, it's going to be scaling a sphere. Let's just set that up. We're going to create a spherical screen. And you can see that in our different views. And if we go look in the perspective view now, we see just the section of the image that's in the direction that we're looking. And the reason for that, I'm just switching back to a wireframe view of meshes. And these black lines are the wireframe of the sphere. So really, all we're doing is we've textured the 360 VR shot onto the inside of the sphere, and that way we always get to see the right portion. And if we scrub through the shot, everything's locked up. We're seeing the portion of the image and the trackers, everything moves together the same way. So that's what we're looking for. So again, you'll see that sphere is actually moving with it. Now, we'd like to be able to look in any direction as well, and we can do that. What we need to do first, though, is just tell it that we only want to lock the position so that when we scrub through the shot, only the position is updated. And that way I can go and I can use the look mode here to go and be able to look in any different direction, and everything is all locked up. And I can still scrub through the shot because only the position is being updated. So that's what we're looking for. And the other part to this, if we need it, is we can adjust the field of view. And if you look down in the bottom left-hand corner, you'll see the field of view number. You can get kind of ridiculous, but it's really better to stay at something more reasonable. So we can adjust that as needed. So now we're ready to get to the inserting part. And right here in the middle, there actually is that one section where we set up the coordinate system earlier. So I'm just going to turn off the display of those trackers to reduce some clutter. And this is where we want to put our inserted building. So let's bring that guy in. So it's a little on the small side. So we're going to use the scaling tool and just numerically rack it up a bit until it gets to be more reasonable. And we'll just move it around a little bit into place. Now, you might say, hey, that was cheating. You're only putting it right where the coordinate system origin is. And of course, that's exactly the point. That's why I put the coordinate system origin there in the first place. The whole point of the coordinate system is always to make it as easy as possible to do what you want to do. So that's what I've done here. Now let's go and bring in a texture. So now we've got a nice little building sitting there, and it's set into the scene. So that's what we're ultimately going to wind up rendering at this next stage of the process. Now, there's a kind of nifty thing about 360 VR shots, which is that the light source is almost always visible. No matter where it is, you can see in all kinds of different directions. So that's something that's really important to get, to be able to feed to your rendering application, to be able to match the lighting for when you're doing the rendering. So in order to generate a matching light, let's use the lights panel to do that. And we'll switch over to the quad view. So I'm just going to create a new light, and then I'm going to move over to the 3D panel and start just moving it around a little bit. So, I can just play with the numbers, or I can drag it around some out here. But actually what you want to do is align it so it's directly underneath the spot you're trying to reach, because then you can just use the Z value to move it into position. So now I've just put the light out in the right direction, but this is actually a key point. We did not make it a faraway light, and we need to because it is very far away, and that makes a difference as to how this all matches up. So let's go back and get that right. Let's just drag it. Oopsie. So I can drag it here. That's a little tedious. So I don't know, we can put it there. And so we've got it in place, and obviously this is a bit of futzing around with some numbers to make that happen. So that makes you wonder, well, is there a better way to do this that might be more accurate? And the answer to that, of course, is yes, there is. So let's take a look at how we can do that. So we go over to the trackers panel, and I'm going to create a tracker and plunk that over here, right smack on top of our sun. And this isn't any sort of super accurate track that's required. So I've just put a tracker there. I'm going to say that it is a faraway tracker again. And I'm going to say that it's a zero-weighted tracker. And bam, so it's just computed the direction to that light. And if we go back to the whole quad view, it's fairly far away based on that world size number. But it's out, sitting at that distance, lined up in exactly the right spot to match our light. Now we want to get to match the real light. So we want to get our computed light, or our virtual light, to be at exactly that same location. If it starts out life just, at the origin or whatever, it may be sitting over here. So how do you get it exactly into place? Well, one super easy way to do that is just to use our handy virtual assistant and tell it to make light one's position tracker. I think, what did we decide that was? Is it 601, I think? This guy. Yep, so we want to make it tracker 601's solve position. Now it's a little wrinkle there. If the tracker's position is actually whatever it is now, where it is in that environment. But we're actually looking for its relative position because it's a far tracker. It's actually, the real number is relative to the origin, and it's only being positioned here so that it shows up in the display right. And we want that actual solve positions. That's what we call for here. Okay. We hit return, and bang, it lines up exactly to the right spot. And this is a process that you can go to exactly locate the light precisely just based on the tracker without having to do any numeric changes as well. And in the case of the far tracker, it's not that complicated to just manually position it. But this same process works for regular lights as well, where instead of using a far tracker, you just use a regular tracker. You have it track where the light is. Then when you do the zero-weighted tracker calculation, it's going to locate it somewhere at some real location within the set. And then instead of using a distant light, you're just going to use a regular on-the-point light, and you're going to do the same thing, and it's going to put that light at the right location within the set. So you can do that to exactly locate all the lights that are relevant in your set within your 3D environment here. So that's one of the kind of cool capabilities that you have in SynthEyes. Now, we've got this. We've got our building set into place there. It's a little on the dark side with the light back there. But anyway, the building is back there. And we didn't want to do that. So the building's back there. It's selected but very dark. And we can go and do the whole render process. But sometimes you might want to just know, right away, can we produce some sort of images here that we can plunk into our 3D viewing scheme and be able to look around at and see how we're doing? And the answer is, yeah, you can do that. If you use the perspective view, you can get the view in a particular narrow direction if that's what you want. But in order to get the full 360 VR view for your 360 VR viewer, you want to get this entire image. So you can actually do that using the image preprocessor, and it has the save sequence dialog here that lets you say that you want to include the meshes as an overlay so that you'll get this entire 360 VR image with the meshes stuck on top. And so you can render that out as a movie or an image sequence or whatever and see your inserted object. Now, it's not going to be a textured object. It's not going to be a fancy rendered object. It's not going to have terrifically anti-alias this, that, or the other thing, or motion blur or anything. But it's a quick and dirty way to look right now and see what you got if it looks like it's going well. So that is kind of a handy capability also. And now we're kind of ready to go and look at what we need to do to get a better rendered version going from the whole thing. So thanks for watching.